Hello, everyone, and welcome to this part of the course. First, let us understand why we use the OpenAI SDK. The OpenAI SDK provides a standard and convenient way to call LLM, although it was originally designed for OpenAI models. Many model providers now support an OpenAI compatible API format. This means that we can use almost the same Python code to code different models, as long as we correctly configure the API key, the base error, and the model name. There are some important parameters. The first parameter is model. It controls which model we are using. For example, we choose to use Kimi K2.6. The second parameter is temperature. This controls the randomness of the output. A higher temperature makes the output more diverse and creative. The draws control is relatively strict, so that we usually set the temperature at zero point 0.1. And this is an example of multi-model compatible codes. Before writing the model calling code, we need to install the OpenAI Python SDK. After installing the SDK, we need to prepare the API key. The API key is used to identify our account when we call the model service. When you run the code yourself, you need to replace the API key with your actual API key. Now we could use the API from the IONET to initialize the client. There are two key parameters here. The first one is API key. This is your personal key for accessing the model service. The second one is base error. This tells the SDK where to send the request. In this website, you could create your API key and copy the API key, replace it there. And in the models part, you could choose your model. Now, let us look at the simplest model code. We use the client chat completion create method to send a chat completion request. In this example, we ask the model about common drawn simulation system. The model receives this question and returns an answer. Next, let us look at the using roles. In the chat completion request, each message has a role. The most common roles are system, user, and assistant. The system role is used to define the behavior of the model. It tells the model what kind of assistant it should be, what roles it should follow, and what output format it should use. For example, we can write it. System message tells the model to behave like a command line assistant. It will not giving a long explanation, only return the best command option. And the user role represents the actual input from the user. In this example, the model will combine the system instruction and the user request, then generate an answer. The third role is assistant. This role is used to store the model's previous responses. If we want the model to remember the previous dialogue, we need to include previous user and assistant messages in the list. Now let us compare single-term and multi-term conversations. A single-term conversation means that the model only receives the current input. It does not know what happened before. It is suitable for tasks such as translation, short QA, simple summarization, or one-time command generation. For example, if the user asks what is the tallest mountain in the world, the model can answer directly. The Mount Everest. This does not require any previous context. However, in a multi-turn conversation, the user may ask a follow-up question. For example, after asking about the tallest mountain, the user may continue, what about the second tallest? If we only send this second question to the model may not know what second tallest refers to. It needs the previous context. Therefore, we need to save the conversation history. Just use the chat history and then append it. After calling the model, we extract the assistant's response and append it back to the history. When the second user question comes in, we append it as another user message. Then we send the updated history to the model. In this way, the model can understand the full dialogue context. And that's all. Thanks.